In the last lectures, we have studied the SMPS, different types of SMPS, four types: flyback, push pull, and half bridge and full bridge SMPS. Okay. So, is there any doubt to anyone in this topic? SMPS, which mode power supply? Is there any doubt? Anyone?
No, sir.
Okay. So let's move for the next topic called UPS, uninterruptible power supply. So can anyone give the answer that where we use this UPS, uninterruptible power supply? All of you, I think, heard this name UPS. Okay. So is there any idea where we use this type of devices? Yes, anyone? And why we require this type of devices? For which type of load? Yes, anyone can give the answer. Okay, so let's understand why we require this UPS and where we use this UPS. Okay, so as you know that in the several applications, the power supply where the load is very critical in nature, like in the hospital ICU room is called as an intensive care unit, where we require the continuous power supply without interruption. If there is an interruption in the power supply, then there is a damage of life. Same way in the several applications like in major computer installation in chemical process plant or any manufacturing plant, where all these things are controlled by this computer, a major computer installation. So you require the continuous power supply to all these computers. Okay, otherwise your plant process will stop. So this type of critical loads you require the continuous power supply. In that time, at that time require the devices which provide the continuous power supply if your main supply is interrupted. So the devices we call in UPS, uninterruptible power supply. That device we use for such type of critical loads. So during the abnormal condition where your main power supply is off, at that time this device provides continuous supply to your critical loads. So that's why we use this uninterruptible power supplies. And application, as we discussed, that used for the use in hospital, in intensive care units, in major computer installation plant, chemical installation plant, or process control plants, communication systems. So these are the applications where we use this UPS, and where we use for this type of critical loads only. Okay. So before the invention of the power semiconductor devices like thyristor, transistor, and all these devices, in earlier days we use the rotating type of the UPS system, and you can see this configuration of the UPS. Earlier days we use this type of configuration to provide the uninterruptible power supply when your main power supply is off. So here you can see the single line diagram. Here we have three-phase supply, which will provide to the rectifier which convert AC to DC. And this DC power is applied to the DC motor as well as that will charge your battery later. And this DC motor is rotated by this DC power that will run the flywheel which is connected with the alternator, and with the same shaft the diesel engine is also connected. So in the normal condition the power is supplied from this three-phase main supply, rectifier, DC motor, and alternator which generate the power and apply to this critical load, normal condition. And then after, suppose abnormal condition happens and your three-phase main supplies become off, in that case we operate this diesel engine, and this diesel engine is connected with the same shaft of the alternator. So this alternator generates the power and provide to this critical load. But the problem is with the diesel engine that the diesel engine is not provide the fast response. The diesel engine takes 10 to 15 seconds to run completely and provide the power to this critical load. So during this 10 to 15 seconds when your diesel engine is completely start, in this duration this battery bank is provide the power to the DC motor and that will run this alternator which generate the power and given to this critical load. So this battery bank is provide the support during the abnormal condition during the running of diesel engine between 10 to 15 seconds. So this battery bank is provide the backup of power, and then after when diesel engine is run completely, at that time power is provided from the diesel engine. Okay, so this is a normal understanding of this previous type of UPS system. In the earlier days we use this type of UPS system. So as you can see that in this case we require the rotating devices like alternator, DC motor, as well as we require the rectifier. So ultimately the cost of this type of system is very high because we require the large maintenance in this type of the system. Like in the diesel engine we require maintenance, motor, alternator, all these things. Okay, so this type of the system becomes costly after the installation. After the invention of the semiconductor devices, we not require this type of configuration. By using the thyristor switch, we can control the power and we can provide the continuous power with this type of critical loads without any interruptions and with the less cost. So let's see that nowadays what type of UPS is used and what is the basic configuration and principle of operation of the UPS system we use nowadays. So because of the disadvantage like huge cost of this earlier UPS system, we not prefer nowadays. We nowadays prefer these two type of the UPS. One is called as a short break UPS, which you also call as an offline UPS, and another one is called as a online UPS, or it also called as a no break UPS. So as the name is suggested, the short break UPS, this UPS, your load is disconnected from the source for a short duration of the time. So that's why its name is given short break UPS. Where in the online UPS or no break UPS, your loads gets continuously connected without interruption in any condition like abnormal condition or normal condition. Always your load is disconnected from the supply. So this is why it's called as a no break UPS system. So let's now understand the operation of offline UPS. So you can see that here is the main supply. Main AC supply will be a single phase or three phase AC supply. So based on that, here rectifier is connected, single phase or three phase, convert AC to DC. That DC power is applied to this inverter as well as it will charge a battery bank. And the output of this inverter is AC, which convert this DC to AC, and then AC is filtered out by using this filter, and then it is applied to the critical load through this normally off and normally on switch. So normally on switch, it means that normal condition this switch is closed, and normally off switch, it means in normal condition when your power supply is continuously connected to the load. In this case, this normally off switch is open. It means in normal condition, power cannot be transferred from main supply to this normally off switch. So normal condition, normally on switch is closed. Here this is the anti-parallel thyristor that is act as a switch. So it is act as a switch. It means that you fire this both the thyristor at the zero crossing instant of the supply. So when positive cycle of supply start, you turn on this thyristor, and when negative supply start, you turn on this thyristor. So full cycle of your supply come across the load cycle. So here this thyristor is just act like a switch. So this is called as a static switch. Okay. So main supply is transferred from supply to the load, critical load through this normally on switch in normal condition. But in the abnormal condition, what will happen when the main supply becomes off? In that case, the battery is already charged, battery bank is already charged. That will provide the power to this inverter which convert DC to AC, and then after filtration of the AC is applied to the critical load through this normally off switch. So in abnormal condition, when your power supply becomes off, the normally off switch becomes closed and normally on switch becomes open. So when abnormal condition is detected, when power supply becomes off, provide the gate pulse to both this thyristor of normally off switch at zero crossing instant, so it will on, and remove the gate pulse of normally on switch thyristor, so it becomes off. So abnormal condition, power is transferred from this battery bank to inverter, filter, normally off switch and critical load. So here you can see that normal condition transfer of the power is from main source, normally on switch and critical loads. And when abnormal condition happens, the transition of power from battery bank, inverter, filter, and normally off switch and critical load. So from normal condition to abnormal condition, the normally on switch become off and normally off switch become closed. So in this transition period, for a short period of time, like 4 to 5 microsecond period or millisecond period, that depend upon the switching on time of the thyristor. In this period of time, your load is disconnected from the source. Yeah, because the transfer of this time, supply is not provided to this critical load in abnormal condition. So if your load is a fluorescent lamp or a tube, then it will have with the illumination. So there is a large dip in the illumination in this duration of the time when your load is disconnected for this 4 to 5 millisecond period. Clear? So that's why it's called as a short break UPS, because short period of time in normal condition to abnormal condition, your load is disconnected from the source. But to avoid this type of short break in the critical loads, you use the online UPS. In online UPS, there is no break in the supply even in the critical load when transfer from normal condition to abnormal condition. So this type of UPS, short break UPS, is generally used for the such type of critical load where 4 to 5 millisecond interruption is not creates any effect. So in that case, we can use this type of UPS. But where for such type of critical loads where you need continuously provide the power supply without any interruption, so in that case you can go for the online UPS or no break UPS. So online UPS is same as a offline UPS. You can see the circuit diagram, all the components are same. Just different is that here this normally on switch is here and normally off switch is here. So in the normal condition, this normally on switch is closed. It means that normal condition power is transferred from main supply, rectifier, inverter, filter, normally on switch and critical load. So during normal condition, the flow of power is this direction. So in this time, your battery is also charged. The DC power comes from the rectifier that will provide the DC to this inverter, as well as that will charge this battery also. Abnormal condition, when your main supply becomes off, in that case also the power is transferred from this direction to this battery bank, inverter, filter, normally on switch and critical load. So in abnormal condition also the normally on switch is closed and abnormal condition also it is closed. So the question is that why we require this normally off switch here. So this normally off switch is used when your inverter is failed, but the chances of the failure of inverter is very less. So this normally off switch is used only and only in normal condition when your inverter is failed. So in normal condition, power is transferred from this direction, but when inverter is failed or inverter becomes open circuited because of any fault happen in the switch of the inverter, at that time you can transfer the power from main supply to the critical load through this normally off switch. So in that case, remove the gate pulse of this thyristor and apply the gate pulse to this thyristor. So power is transformed from main supply to this normally off switch and critical. But the chances of the failure of inverter is very less. So as you can see that normal condition the power is transformed in this direction and abnormal condition also in same direction. Clear? So these are the advantage of using the online UPS, that without any interruption your loads gets the power. So for such type of load like in ICU, in the intensive care unit in hospitals, you require the continuous power supply without interruption. So you can go for this online UPS. Okay, but in some process plants, short interruption is not create much effect economically. So in that case, you can go for the short break UPS. All of you understand this concept, online and offline UPS? Is there any doubt? Anyone?
No, sir.
Okay. Now tell me that what are the another advantage of using the online UPS as compared to offline UPS? Anyone can observe the advantages. Think about what are the advantages that given by this online UPS as compared to offline UPS. Anyone?
Sir, आम्ही filtered output મળશે આપણને.
Yes, but that is not an advantage because you can see that in the offline UPS, the normal condition power is transferred from a main supply to normally on switch and load. Okay, so this power is already pure sine wave or near to the sine wave because that is provided from the main supply. Why we require the filter here? Because the output of the inverter is not a pure AC, so that's why we require the filter circuit here. Okay, so that we not called as the biggest advantage of using the online UPS. Okay, the filter requirement is here because of the AC output we get from the inverter, and inverter is not provide the pure sine wave. The output of AC from this inverter is not the same like provided from the main supply, because in the switching of this inverter creates the harmonics, so your output is not pure AC, and that's why we require a filter. Okay, that is not an advantage. But what is the advantage of using the online UPS? You can see that normal condition in the online UPS, power is transferred through this inverter. So as you know that for any of the critical load frequency, you can get the power through the inverter. Through the inverter, you can convert the DC into AC of any frequency, 50 Hz, 60 Hz or 100 Hz, depending upon the requirement of the load. So that is the biggest advantage of using this online UPS, that you can control the frequency of this AC power which is provided from the main. Suppose you have AC supply 50 Hz, but for a critical load you require the 60 Hz frequency. So you can use the online UPS, so through this inverter you can get the 60 Hz frequency. But that is not possible in case of offline UPS. If your supply is 50 Hz, then you can get 50 Hz only at the critical load. Okay, so that is the one of the advantage of using the online UPS. Second advantage that in offline UPS, you can see that during the transfer of normally on switch to normally off switch, the transient dip happen in the critical load. So transient in the supplies happen in the offline UPS. So sometimes the transient in the supply may damage your critical loads. But that cannot possible in case of online UPS because there is no interruption in the supply. So there is no transient to the critical load. So that is the second advantage of using the online UPS. And another advantage, you can see that in the online UPS, you not just control the frequency, but you can also control the voltage also. So depending upon the voltage requirement or power requirement at the critical load side, you can change the firing angle of this inverter switch so that you can control the power also. That is called as the conditioning of the supplies. So these are the third advantage of using the online UPS. Control the frequency as well as control the power. And third one is your load is protected from the transient, because there is no transient happen in the online UPS like happen in the offline UPS. So I hope all of you have understood all these advantages of online UPS. So generally we prefer to use this online UPS in normal applications. So nowadays in the online UPS, the batteries which we use as a backup, that is nickel cadmium type or lead acid type of the batteries. The advantage of using the nickel cadmium battery is that the electrolyte we use in the nickel cadmium battery is non-corrosive. It means there is no corrosion happens if you use for the number of years. Second advantage of using this nickel cadmium batteries is that it will not emit any explosive gas when it is charging. As you know that some of the batteries that emit the explosive gas when it is charging or discharging, but that not happen if you use the nickel cadmium batteries. And one of the main advantage of using the nickel cadmium battery is that it cannot damage by overcharging or discharging, so that it has a longer life. So normally in the UPS prefer the nickel cadmium batteries, but the problem with the nickel cadmium battery is that its cost is very high. It is 2 to 3 times more than the lead acid batteries. So if you require the UPS system and if cost is the main criteria, then you go for the lead acid battery. Otherwise, you can use the nickel cadmium type of battery bank in the UPS system. So these are the whole simple understanding of the types of UPS, how it is operated. So with that theory also we implement in the simulation in the MATLAB, so you can clearly understand how your UPS system is working. So in this today's in Friday lab session we will simulate this UPS, both online and offline UPS, so you can get the clearly idea about it. So here I complete this topic, online and offline UPS. Is there any doubt to anyone in this topic? So if you not doubt, then I will move for the next topic. Yes, anyone? Is there any doubt? Okay, so let's move for the next topic, that is called as the static switches. So as you can see here in the UPS system, we use the normally on and normally off switch. That is just act like a switch. It means that we provide the firing and delay at the zero crossing instant of the supply. So there is no control of the power. There is no change in the power what is provided from the supply to this load. So that is just act like a switch. It connect or disconnect the supply to the load. And it is called as a static switch because there is no moving parts. So before the invention of these thyristors or all thyristor family devices, we normally prefer to use the mechanical or electromechanical switches. You can see the example of this mechanical switch like this electromechanical plunger. Okay. So in this type of switch, what will happen when you provide the energy to this coil? By the electromagnetic induction, this plunger will attract it downwards and that will make the contact close. Then after your load is connected to the source. Clear? But in this type of mechanical switch, the response time is less, and because of some other disadvantages, will not prefer nowadays. So what are the other disadvantages? Like mechanical switch, response time is less. Another disadvantage that it is a moving device, so you require the large maintenance. And when this type of switch is closed, that creates the bouncing effect during the on condition. So this bouncing effect will create the transient in the load, because when closed, after that it becomes open for a very short period of time because of bouncing effect. So that will create the transient in the load. So to avoid this type of disadvantage, we now generally prefer to use the static switch. Once it is closed, it's connected load to the source directly, and when you remove the gate pulse of the switch, then it's disconnected from it. So all these advantages of the static switch. So nowadays we prefer this type of switch in the relays as well as in the circuit breakers. And one other main advantage of using the static switch is that its switching time is very less in terms of microseconds. So you can provide the fast switching to any application if you require. You can go for the static switches. So here you can see that there are two circuit diagrams. One is we use the triode as a static switch, and in another figure we use the two thyristor in anti-parallel connection as a static switch. So whenever you require this circuit is closed to provide the gate pulse at zero crossing instant, so whatever supplies that connected directly to the load, and if you remove this supply, if you not require supply at the load side, just remove the gate pulse. So it's just disconnected and works like a switch. Same way here, provide the gate pulse to both the thyristor. This thyristor during positive cycle and this thyristor during negative cycle through this firing circuit. So by applying or removing the gate pulse, it is just like a switch. But here apply the gate pulse at the zero crossing instant of the supply. So there is no control of the power, or there is no control of the voltage happens here. Yeah. So this type of switches are available in the market in two categories. One is called as the AC static switch. If your supply is AC, then you can call as the AC static switches. If your supply is DC, then you go for the DC static switches. Generally for the AC static switch, we prefer triac and thyristor. For the DC static switch, we generally prefer the transistor or MOSFET. Yeah. So these are the example of how it is used. Thyristor and triac as a static switch. So you can see that at the zero crossing instant, apply the gate pulse to T1 and T2. T1 apply the gate pulse at zero crossing instant of positive cycle. T2 apply the gate pulse at zero crossing instant before the negative cycle starts. So you can see that at the load side, voltage V0 across the load, you get same as the supply voltage. And when you not require the supply at the load side, you just remove all these gate pulses. So you get the zero voltage. So it is just like a switch. Same for this triac also. You can see that for the triac also you get the same power. So these are the waveform for the resistive load. But suppose there is an inductive load or RL load. At that time, provide the firing angle when your load current is reached to the zero value. So you can see that supply voltage is this. You provide the gate pulse when your load current becomes zero or supply current becomes zero. So load current becomes zero when whole energy stored in the inductive load becomes zero. So it means at angle phi you apply the gate pulse. It means your firing angle alpha, that is equal to power factor angle phi. So you can see that at load current 0 at angle phi you apply the gate pulse Ig1 to the thyristor T1. Same way at pi plus phi we apply the gate pulse to thyristor T2. So you can see that you get the continuous current sine wave without any interruption. So this type of configuration you can use for the RL load as well as resistive load. Just act as a switch. Without any interruption, it will give the power. So I hope all of you understand the application of AC static switch. In more detail, we will study in the next topic where it is used in the relay circuits. Okay. So this is the application of thyristor as a switch. This is the AC switch. Same way this configuration also you can use where we require the 4 diodes and 1 thyristor. So whatever supply, same supply you get the load side. Now let's understand how your DC static switch works. So as I told you that the DC static switch we use the transistor or you can go for the MOSFET. So here you can see that the one circuit diagram through which we understand the operation of this DC static switch. Here load is connected, here your DC supply is Vs. Here we use a two switch. Assume that suppose there is a transistor T1 and this is the auxiliary transistor TA. During normal condition, you turn on this transistor, you can turn on this thyristor so that it will turn on and your DC supplies gets directly connected to the load side. But when you require to turn off this switch, at that time it will turn on by this capacitor. Initially your capacitor is charged with this polarity, upper plate minus, lower plate positive. So whenever you require to turn off this main thyristor, you turn on this auxiliary thyristor by applying the gate pulse. So what will happen? You can see the equivalent circuit is look like this way. When auxiliary thyristor is turned on, what will happen? The positive polarity of this capacitor come at the cathode side and negative is connected with the anode. So your main thyristor come into reverse bias. And current is flowing from main supply capacitor, now it's discharging because upper plate is negative, which is now directly connected to the positive of the supply. So when TA means auxiliary thyristor is turned on, your capacitor is discharged from positive to negative value and current is flowing from supply, capacitor, auxiliary thyristor and load circuit. So in both the condition, your load is connected to the source, but In this case, when auxiliary thyristor is turned on, that will remain turned on until your capacitor is fully charged with the upper plate positive and lower plate negative. Initially it is charged with minus and plus like this. Okay. And normal condition T1 is on, so power is flowing from supply T1 and load. But in abnormal condition, power is transferred through auxiliary thyristor. And once the capacitor is fully charged with upper positive and lower negative, what will happen? Your capacitor is act as an open circuit, so there is no flow of power through the auxiliary thyristor. And your main thyristor is already off, so that your load is disconnected from the supply. So whenever you require to turn off this supply from the source, you first turn on the auxiliary thyristor, and after some time, your auxiliary thyristor is also become off because your capacitor becomes open. So like this way, your DC static switches works. The difference is that in DC static switch, we use the transistor, but for clearly understand the concept, here we use the thyristor. Okay. So you can see the another example that where we use the DC static switch, like using the transistor. Here you can see that by applying the base circuit, by applying the base signal at the base terminal of the transistor, you turn on this BJT. So your loads connected to the source directly. If you remove the base signal, that become off, load is disconnected to the source. Same way you can use the GTO as a DC static switch. As you know that gate turn on thyristor. If you apply the positive gate pulse, then it will turn on. And by applying the negative gate pulse at gate terminal, it will turn on. So depending upon the requirement at the load side voltage, you can turn on and turn off and works the GTO as a static switch. These are the example of using the DC static switch. I hope all of you have understand this concept. Is there a doubt to anyone in AC and DC static switches? Yes, anyone? And why we use these static switches? What are the advantage as compared to the electromechanical or mechanical type of switch? Is there a doubt to anyone? Yes or no? Okay. So let's move for the next topic. That is a solid state relay. So as we have discussed the static switch and its advantages, like it provides the fast switching operation. It means fast on and off. So this type of switch we can use in the circuit breaker to turn on and turn off the contacts. Normally, you know that we use the mechanical contact in circuit breakers. But after the invention of this thyristor device, which is operated very fast, so nowadays we use these thyristor based contacts, which provide the connection or disconnection of a load to the source. Clear? And another application in relay also you can use this type of switches. So this is the application of static switch in relays. In relays, as you know that you must provide the isolation between power circuit or a control circuit and your load. So you require the isolation devices like optocoupler or phototransistor. Or you can also provide the isolating transformers. So here you can see this figure. We use the optocoupler by using the photodiode. So here it is your load. Here your main supply DC. You want to connect this load. So you can connect the source to the load through this photodiode. But you must provide the isolation between control circuit and power circuit. So you can see that here you turn on this photodiode by using the infrared light emitting diode. By applying this signal V1, this infrared light emitting diode emit the light on this photodiode. As you know that photodiode it will turn on when you provide the photon on this PN junction of this diode. Then and then it will turn on. So by infrared light emitting diode you can turn on this photodiode, and once this diode will turn on, your source is connected to the load. So this block is called as an optocoupler because this provides the isolation between this power circuit and this control circuit. So this type of configuration you can use in the solid state relays. to connect or disconnect the contacts. So as you know that the working of relay is what to sense the fault and after that provide the signal. So that signal is just like in terms of voltage. Suppose this is the signal to turn on the contacts. So this reverse signal turn on this infrared light emitting diode which generates the photons and that applied to this diode here in this figure. Same way if you use the phototransistor, then here this phototransistor will turn on and that will close the circuit and provide the power to the load. There are two categories of solid state relays. One is based on the optocoupler. In optocoupler there are two categories. One is by using the photodiode. Here you can see that we use the photodiode and another one you can use the phototransistor. So this is called as a optocoupler based relay and another relay is based on the transformer which is called as the AC relay. So normally for the DC solid state relays we generally prefer to use the photodiode and transistor and for the AC solid state relay we use the optocoupler transformers. So you can see that the application of this DC solid state relay where we use a static switch, phototransistor as well as static switch in optocouplers. So here this is the control signal applied with the ILED, infrared light emitting diode, generate the light, turn on this phototransistor and the output of this phototransistor that is applied to the base of your main transistor. So when main transistor will turn on, then and then your supply is connected to this loop. So you can see that here the A meter current of this transistor acts as the base current of the main transistor. So whenever this main phototransistor is turned on, then and then your main transistor will turn on and your load is connected to the source. So by applying the control signal VC to the ILED, phototransistor is turned on, that will turn on your main transistor and your load gets connected to the source and make the closed path. So by this way your DC solid state relay works. Same way you can also provide the isolation in the AC solid state relay where we use the same optocoupler by using the phototransistor as well as you can also use the optocoupler transformers or normal transformer solid state relays. Okay? So you can see that in AC solid state relays using the optocoupler, here your supply is AC, that's why it's called as the AC solid state relay. In this case your supply is DC, or main power circuit is supplied DC, so it is called as the AC solid state relay. So in AC solid state relay, the same function of this optocoupler, you can see the control signal is here applied to this ILD which will turn on this phototransistor and this phototransistor, through this phototransistor we provide the gate pulse to this triode. Let's understand that how this AC solid state relays works. Here your main supply is here, your load is here, in series we connect this triode. Triode is your main switch which is just work as a static switch. So when positive supply is here and negative is here, the current is flowing from this positive terminal to this resistance, then diode D1 forward bias, control signal is applied here, so your phototransistor is turned on. So through this phototransistor, current is flowing into D2, diode, gate terminal of this triode and then source terminal. So by applying this positive terminal of the supply, current is flowing resistor D1, phototransistor D2 and gate terminal and source. Your triode will becomes act as a closed switch. So then after your source is connected to the load side like this. Same way during negative cycle of the supply when lower terminal positive, upper terminal is negative, gate signal is applied from the source, here positive, source to gate terminal of triode, current is flowing into D3, phototransistor, D4, resistance and now negative terminal of your supply. So by this way you can provide the gate signal to the triac and it will turn on and your loads gets connected to the source. Here the function of this resistor is to limit the gate current when provide the supply from the directly from the main supply. So to limit the gate current, you can use the transistor. You can use the resistor of suitable amount so that you can limit the gate current. So these are the application of static switch of triac in AC solid state relay using the optocoupler. Same way you can use the optocoupler opto transformer in AC solid state relay. Yes.
In last, what is the function of Zener diode?
Yes, the function of Zener diode is here to block the voltage. Suppose assume that here will not provide the Zener diode. What will happen? Suppose here there is no any device. So when you provide the gate signal from positive resistor, what will happen? Here the current is flowing into this direction. It will not flow through this diode and phototransistor. Okay, it will directly connect the resistors and supply. So it means that your load is your source is connected with this load. Clear? But we require to connect your source with this load. Okay. So this Zener diode is just to provide the blocking of the voltage. As you know that Zener diode is work in the reverse bias mode. Okay. So whenever you apply the positive voltage from the source, your Zener diode is in off condition. So that will block the voltage. So it is just like open circuit in this path. So current will not flow into this direction. So current is flowing from resistor to diode because this path will provide the least resistance path as compared to this Zener diode. Yeah. Same way in the negative direction also this Zener diode provides the high resistive path. So current cannot flow into this direction. So negative direction, this is a positive, this is negative. So current is flowing from supply source to gate terminal and then D3 phototransistor and D4. Clear? So if you not provide Zener diode, that will flow through this path and through this resistance. So your load never connected to the source because your triac will not turn on if you not provide the Zener diode. Understand?
Yes, sir.
Okay. Now, in the second type of AC solid state relay, we use the transformer. So here we transfer the control signal to the switch using this isolated transformer, opto-isolated transformer. So control signal applied to the primary of the transformer, same signal transferred to the secondary side, and secondary side connected with the gate and another terminal of its triac. You can see the MT2 terminal or MT1 terminal because there is no anode cathode terminal in the triac. So secondary terminal is connected with the gate terminal and this second terminal of this triac so that it will turn on this triac and your source is connected with this loop by turning on this triac. So whenever control signal is removed, there is no gate pass at the secondary side of the transformer, triac will remain open. So there is a disconnection of your load to the source. So that is called as the AC solid state relay because you use the supply is AC and use the pulse transformer here for the isolation. So it is called as the AC solid state relay using the pulse transformer. Clear? So here this isolation is provided by the transformer just for the protection of your control circuit from this power circuit. So here this isolation is provided by the transformer. In the previous figure, this isolation is provided by this optocoupler, in which we use the ILED and this phototransistor. Clear? And it is a solid state relay because there is no moving parts here. So it is a static type of the relay. So nowadays in the circuit breakers or in the digital relays, we prefer to use this type of relay because this type of relays operation is very fast as compared to the mechanical relays or mechanical circuit breakers. Understand all of it? The application of static switches. in circuit breakers and relays and how it is used. Is there any doubt to anyone?
No, sir.
Here this chapter is over, power supply, in which we study from the first topic SMPS, different types of SMPS, flyback, push-pull, up-bridge, full-bridge. And then we understand through the simulation, MATLAB simulation. Then after today's lecture, we start with the UPS, uninterruptible power supply, in which there are two categories. One is short break UPS and no break UPS. Nowadays, which we use normally online UPS. In the previous days, we used the normal rotating type of the UPS, which we use the DC motor and alternator set, but it is economical, very costly. After the invention of the semiconductor devices, nowadays we prefer to use this online and offline UPS. Now, then after we use this static switches for the different applications like in circuit breaker context, in relays or context to provide the fast switching speed. So these are the topics which we cover in this chapter. If you have any doubt in this chapter, you can ask the question. So in the next lecture, we have started this next final chapter that is called as the AC drive. Okay, that will start in the next lecture. So here I stop this lecture if you are not any doubt in this lecture. Okay. So ask your doubts if you are any, otherwise you can leave this meeting.